So we're back again. And this time we're looking at our fourth property for today, which is the power property. So let's get on that. And we notice that this is the power property for logs. And another smiley face. Why not? So power property, that sounds like an exponent. We just looked at that log of an exponent property. So think about this is the power property. And what does it say? It says that the log base B of, all right, this is different. This time, what? The argument is a different number. In the previous example, we looked at log base B of B to the Y. But this is log base B of A. So the base and the argument are different numbers. The answer is not just P like it was in our previous example. Log base B of A to the P. So this makes sense if you think back to exponent rules. And again, in exponent rules, what's happening? Well, if I have 5 to the third and I raise that to the second power, that becomes 5 to the 3 times 2, which is 5 to the sixth. When you take a power to a power, you multiply the exponents. And remember, a log value is an exponent. And this is an exponent. So an exponent raised, what are we going to do? An exponent raised to a higher power, we're going to multiply them. So what is the special rule? Well, this is pretty cool. This guy just comes right out front. And we can rewrite it like this. The log base B of A to the P is the same as P times the log base B of A. That's the power property. Pretty nifty. The exponent on the argument becomes a multiplying factor out front. So let's jump in and see what this might look like. Not only can you rewrite it with the power, putting it out front like this, if I needed to expand something, if I need to condense it to solve, and I have a power being multiplied out front, I can take it and put it right up here in the exponent spot, and it'll look like this. So again, not just going left to right, but it also works going right to left. Let's look at example 3, our fourth property, but really our third type of example. So I have the log base 3 of 9 to the fourth power equals x. So what do we notice? Well, we notice I just have a log on one side. I don't have logs equal to each other, so I'm not using the log property of equality. I don't have a sum or a difference, so I'm not using the product property or the quotient property. Well, what do I have? Well, I got this exponent on the argument. Okay, so is it the log of an exponent? Well, look right here. These are not the same. If it were log base 3 of 3 to the fourth, we would say, oh, it's just 4. But it's not. It's log base 3 of 9 to the fourth. Oh, okay. So I can't just straight up use the exponent, log of an exponent. But I can do this power rule. And the power rule says if you have an exponent on the argument, you can take it and send it out front and multiply it by the log value. That's what this is. So that's what we'll do. We'll try a property and see, hey, does that help? And sometimes it's just like, I know 5 things to do. Let me see I'll try this one and see if that helped. Did that help? Oh, great. And if you do it and it didn't help, then what? Put it back and try something else. So let's stick the 4 out front. So I'm going to say 4 times the log base 3 of 9. And what did we use? Well, we used the power property. The power property says that we can do that. And now we're looking at that and going, well, I don't know if that really helped or not, because I don't know what 4 times log base 3 of 9 is. So did that really help? Well, we do know that if my base and my argument are the same, then my value is my exponent up here. So then the question is, well, could I use this power property in conjunction with the log of the exponent rule? So we start thinking, is there any way that I can rewrite 9 using base 3? There is, isn't there? Yeah. So we're going to use the log of an exponent rule. We know that 9 is equal to 3 squared. So I'm going to take 3 squared and substitute it in right here. 4 times the log base 3 of 3 squared. And now looky here. Log base b of b to the y. So log base 3 of 3 to the second is 2. So here's my side business. Log base 3 of 3 to the second is equal to 2. Log base b of b to the y equals y. So I can take all of this business and replace it with, guess who? 2. That's pretty cool. So 4 times all of this, which equals 2. And now we're flashed back to 3rd grade. Oh my gosh, look how complicated this was. And then all of a sudden, now we're in 3rd grade. 4 times 2, which is 8. Yippee! We did it! Yahoo for you.